curve has the equation y is equal to 5x minus 4. The normal to the curve at the point where x equals 4 meets the x-axis at point P. Work out the coordinates of the point P. Again, it's a good idea maybe if you could draw a sketch of the situation or use some technology. So I've used GeoGebra, or you could use your GDC to sort of draw the situation. So here we have the graph of y is equal to 5x minus 4. Here we have the tangent drawn where x is equal to 4. So we'll need to find out where y, the value of y at that point at some stage. The normal is perpendicular to the tangent, and therefore we will then need to work this out, the gradient of this normal, and then be able to find the coordinates of this point here. Okay, so sketching it or drawing it with some sort of technology would help us to visualize the problem and help our understanding. So using y is equal to square root of 5x minus 4. Before differentiating, we'll need to write it as 5x minus 4 to the half, knowing that the square root of a is equal to a to the half. So knowing your rules of indices is important. Differentiating using the chain rule, dy by dx, so we'll bring down the half first, write down the bracket 5x minus 4, reduce the power, so half minus 1 is minus a half, and then don't forget to differentiate the bracket, which is 5. Now write your fractions one above the other, and then this bit becomes very easy. So rewriting this becomes 5, because it's all we've got in the numerator, over 2 times the square root of 5x minus 4, using the idea that a to the minus n is 1 over a to the n. Right, when x is equal to 4, dy by dx will be equal to 5 over 2 times 5 times 4 minus 4. 5 fours are 20, 20 minus 4 is 16. Square root of 16 is 4, 2 fours are 8, so this becomes 5 over 8, or you could use the fraction button on your calculator. Now you need to remember that this gives me the gradient of the tangent. What I need to be able to do from that is find the gradient of the normal. So the gradient of the normal is perpendicular to the tangent. So if this is 5 over 8, then the gradient of this one will be minus 8 over 5. The reason being that 5 over 8 times minus 8 over 5 is minus 1. This is the condition for perpendicular lines. We also need to find the y coordinate. Okay, we can see it's 4 from the graph, but we have to show algebraically. So just putting 4 in the original equation. So 5 times 4 minus 4, that gives me the square root of 16, which is 4. And now we can find the equation of the normal, the equation of this line here, by using y minus y1 is equal to mn x minus x1, or you can use y is equal to mx plus c. So, substituting in the relevant information, we're going to have, this is mn, x1, y1, so we're going to do y minus 4 is equal to minus 8 over 5 times x minus 4. Notice again I wrote in my fraction one above the other. Take the 5 and put it up in front of here. So 5 times y minus 4 is equal to minus 8x, expanding the bracket, minus 8 times minus 4 gives me plus 32. Be careful with the sign. Expanding this bracket here, we're going to have 5y minus 20 is equal to minus 8x plus 32. So collecting over here, we're going to have 8x plus 5y, and then minus 32 over here will give me minus 52 is equal to 0. Right, we need to find where this line cuts the x-axis. On the x-axis, y is equal to 0. Therefore, 8x plus 5 times y, 5 times 0 minus 52 is equal to 0. That's going to give me that 8x is equal to 52. X is equal to 13 over 2, which is 6.5, which we can see there from the graph. So the coordinates of P are 13 over 2, 0, or 6.5, 0. Okay, this has been a video to show you how to use the chain rule to find the equation of the normal in order to find where the normal cuts the x-axis. I hope you've understood, and I thank you very much for watching.